Amit, welcome to YourPedia. Introduce yourself.
Uh, Good afternoon, ma'am. I'm Amit Kumar Patel. I come from Kusinor district of Uttar Pradesh. I did my BTech in Civil Engineering from National Institute of Technology, Meghalaya. Uh, I did my BTech project in Transportation Engineering, and my topic was use of mining waste in open-graded friction cores.
Tell me the difference between permeability and porosity.
Ma'am, if I'm talking about permeability, so permeability is the ability of soil to allow the water through interconnected void, uh, allow the water to pass through interconnected voids. And if I'm talking about the porosity, so porosity is the uh, capacity of soil to hold the water. So porosity is basically volume of void present in total sample. So volume of void in
Okay.
total volume of sample.
Uh, which is more significant, void ratio or porosity?
Ma'am, generally we use wide ratio in case of geotechnical engineering, but if I'm talking about significance, so I think porosity is more significant than uh, wide ratio, because porosity we see number total pore in soil sample.
Porosity is more significant.
Yes, ma'am. But basically, in geotechnical engineering, we use wide ratio more, because wide ratio can go up greater than one also, but porosity will be less than 100% only. And here we consider total volume. So in total volume, we are
Void
saying
ratio can be greater than 100% also.
it can E can be greater than one also. Yes, ma'am.
Are you sure?
Yes.
Write the formula for void ratio.
Ma'am, volume of void in volume of soil solid.
Okay, so for E to be greater than 1 means volume of void can be greater than volume of solids.
Hmm.
Is it possible?
It is possible, ma'am. It can be when volume of if you are talking about volume of void, it means volume of water and volume of air both we are taking here. So it may be volume of water can be greater than volume of solid.
When will void ratio be equal to 100?
Ma'am, when a volume of void will be equal to volume of solid, so it will be there. Uh, yeah, when volume of void will be equal to volume of solid.
Can void ratio be equal to 0?
Void ratio, like hypothetically it can be, but it's practically it is not possible, because volume of void will not be zero. Like volume of voids will be there always. It can be air void or it can
Then
be
how is it
void will be
possible
there.
hypothetically?
Ma'am, like I mean, hypothetically means if volume of void is becoming zero, then void ratio can be zero. But volume of void will not be zero in practical scenario. So that's why practically it is not possible.
Uh, Tell me, just draw the compaction curve of clay and
Hmm.
explain me that.
Ma'am, for this compaction curve, we do Proctor test. So here basically we are trying to find out the minimum water content at which we can get the maximum dry density. So for that, actually, what we do, we provide some water content and we do compaction, and during that we find dry density, and we make one curve. So that curve we get for soil. Basically, I'm talking about soil. So basically, in case of clay soil, we'll get one parabolic shape, that will be downward parabola. So corresponding to the peak, I mean corresponding to the highest value of dry density, whatever water content will be there, that will be called as optimum water content, and at that water content only we perform the compaction.
Why is it that dry density is decreasing after OMC?
Ma'am, if we will yeah, so if we will increase the water content, and we are doing compaction, so uh, due to increase in water, the soil sample will not come together. It means compaction will not be there, and the soil sample will go, solids will go far away from each other, and in that case, we'll be getting that it will decrease, like dry density will decrease. Since we are talking about dry density means here solid particles should be should be denser actually. Those should be very close to each other. I mean, air void should be minimized. So, but if we are giving some more water, it means what we are doing, we are simply replacing the air void by water, and in that case, we'll be getting that soil solids will be going far away from each other, and density will decrease.
Okay, explain standard penetration test.
I mean, standard penetration test, basically, we applied in borehole. So there we give us uh, a penetration of 450 mm. In we do we check the value of n. The value of n is the number of blows given on the this standard penetration. So we give we check for 150 mm for each 150 mm, and first 150 mm will be there for driving, will be there for setting this thing. So we see the value of n for only three last 300 mm uh, settlement. So penetration. So basically here we are doing the hammering for this one. So we take the hammer of 63.5 mm, and the free fall will be 750 mm. And in this from this standard penetrometer test, we get relative density and friction angle.
So,
And here generally we do two type of correction also. One is dilatancy test, dilatancy
so
correction.
this test gives us information related to what? What
Which one?
information does this test provide us?
This provides us about the relative density of soil, where the density is high, and it tells us about the friction angle.
Okay, so it is only telling us about the density index and friction angle.
Ma'am, if it will be telling density, so from there we can calculate the bearing capacity also. It means where where the soil strata is able to bear the load of the structure. We can find the
So
depth also.
how can we calculate that bearing capacity from this test?
Ma'am, bearing capacity, one formula is there, ma'am. From here we find, sir, ma'am. Ma'am, actually here we have one chart. Using that chart, we see for particular value of n, we have the relative density, and for that relative density, particular value of relative density, uh, we have the friction angle. But I'm not sure about the bearing capacity. Bearing capacity, we can see like for 300 mm penetration, how much the value of n is we are giving, and corresponding to that n, we can find the load, and load divided by area we can do to find the capacity.
What does this n signifies?
And signifies the number of blows given
So
for
how are
penetration.
you dividing the number of blows and getting the bearing capacity?
No, I'm not saying number of blows, ma'am. Like for number of blows, we'll be getting some resistance from the soil. That resistance will be divided by the area.
So in this standard penetration test, you are getting the resistance or you're getting the number of blows?
Number of blows we are getting, but from there, I think we can calculate actually. I'm not sure actually, because we
There
have
are
one
some
chart.
empirical equations with the help of
Huh.
those. We
Hmm.
put the data, we put the values of n after correcting them in those equations. Then we
Hmm.
get the bearing capacity. Okay.
Okay. Oh.
What are those two corrections?
Ma'am, we have overburden pressure, and then we have dilatancy correction.
Okay. In which kind of soil do we provide dilatancy correction?
Dilatancy correction we are providing in like in sandy soil.
In sandy soil?
Yes, ma'am.
In all types of sandy soil?
It will be, I think,
Why not in clay?
Ma'am, here we are talking about dilatancy. It means like, sorry, ma'am. Here we are talking about granule soil, ma'am. Actually, if we will be having two layer of ma'am, dilatancy. Dilatancy means, ma'am.
What do you mean by dilatancy test? Why do we provide this correction?
Ma'am, we are here seeing the I mean correction because of poor water pressure, I think. Not really sure.
Okay, tell me the classification of soil.
Ma'am, classification of soil is basically done to check whether the soil is gravel, that is silty soil,
Tell
clay
me
soil.
the size. Tell me the size range of gravel and sand.
Ma'am, for gravel, as you can remember, for gravel, the size of particles should be more than 4.75 mm. I mean, if we are doing gradation of soil, so the particle remaining at 4.75 mm CU should be uh, greater than 50%. And if we are talking about fine sand, so in case of fine sand, it will be, I
Tell me the
mean,
size range for gravel and sand. Size range I'm asking.
ma'am, for sand, it will be 4.75 to 2.36, and for gravel, it will be more than 4.75, and for silt, it will
No,
be
it is
2.
not. Gravel size range is 4.75 mm to 80 mm, and sand is 75 micron to 4.75 mm.
75 micron.
Okay, my
Okay,
last question. What
okay.
are the lab methods that we have to find the shear parameters of soil?
Ma'am, we have direct shear test, we have triaxial test, we have bend shear test.
Okay.
Yes, ma'am.
What is triaxial test?
Ma'am, triaxial test is done for almost all type of sand, all type of soil actually. And here we do test in two stages. When we have like in one case, we generally allow the soil to drain the water, and or we can restrict that also. So we have, first thing, either we can do consolidated or we can do unconsolidated, and in second stage we do undrained and drained. It means we are allowing the soil sample to decrease the volume. Decrease the volume means we are doing drained, it means water can go out. And while in the second thing we are doing undrained, it means while soil will not change the volume, it means we are not allowing the water to go out. So basically, we have uh, three types we can do here. One, we have consolidated drained, then consolidated undrained, and then we have unconsolidated drained.
Why is unconsolidated undrained test not possible?
In realistic scenario, it is not possible because in first case we are doing unconsolidated. It means we are not allowing the water to go out, and then again we are doing undrained. Undrained means again we are not allowing the water to go out in second stage also. But if we are doing consolidation and all, so water will go out. So this is not possible like in real scenario. So that's why we do not use this test.
Unconsolidated undrained is not possible, but unconsolidated drain test is possible.
Unconsolidated drain. Ma'am, I'm confused actually. Unconsolidated drained is not possible. Unconsolidated undrained is
But
possible.
you told me the procedure of UD test. Okay, Amit, I'll provide you the feedback now. You know your faults, right? The basic things, size range. You should be knowing those.
Okay.
लेवल का क्या साइज होता है, सैंड का क्या साइज होता है. स्टैंडर्ड पेनिट्रेशन टेस्ट में एन जो होता है हमारा एसपीटी नंबर, क्या हमें नंबर ऑफ गोज बताता है ना. पेनिट्रेशन वाली तो ना मिलती है हमको, वो तो कौन
हाँ,
पेनिट्रोमीटर से मिलता है आपको रेजिस्टेंस.
yes,
कौन पेनिट्रोमीटर से आप उस वैल्यू को कोरिलेट करते हो. यहाँ से तो आपको नंबर ऑफ ग्रोज मिलते हैं. तो आप इंपेरिकल इक्वेशंस भी है, पैक्स इक्वेशन है, टैंक्स इक्वेशन है, आईएस कोड ने इक्वेशन दी हुई है, उसमें आप उसको पुट करते हो, आपको बेयरिंग कैपेसिटी मिल जाती है, राइट.
okay.
पर पोरोसिटी और वॉइड रेशियो में, वॉइड रेशियो किसका रेशियो, वॉल्यूम ऑफ वॉइड्स अपॉन वॉल्यूम ऑफ सॉलिड्स. वॉल्यूम ऑफ सॉलिड्स तो कांस्टेंट मान के चलते हैं ना हम, बट पोरोसिटी क्या है, टोटल वॉल्यूम ऑफ वॉइड्स अपॉन टोटल वॉल्यूम. तो टोटल वॉल्यूम क्या हो सकती है, कम ज्यादा हो सकती है. तो ये पैरामीटर क्या होगा आपका, वेरी करेगा नहीं करेगा. तो वॉइड रेशियो का सिग्निफिकेंस ज्यादा होता है. ठीक है, तो ये छोटी छोटी सी गलतियां अपनी, इन पे थोड़ा इम्प्रूव करो. एनी मोर क्वेश्चन?
No, okay, ma'am. 120. Okay, ma'am.
Okay, you can leave now.
Okay.